Archaeologists, paleontologists, geologists, and anthropologists study ancient artifacts like rocks, bones, tools, pottery, and metal objects. In the process of reconstruction of the past, determining the age of such artifacts is necessary. The act of finding age of ancient items is called dating. What is the science behind it? Let's find out. Hi friends, my name is Akhilanand Singh. Welcome to the Archaeological Artifacts dating series. Under this series, we'll be learning about various methods developed to find out the age of artifacts found in excavation. The series aims at fulfilling the requirements of the topic 1.8 of the UPSC Anthropology optional paper 1. I have tried to keep the video series as generic as possible. It should also be useful to students learning about radioactive elements and their uses in dating the things of past. At the broad level, there are two dating techniques: the relative dating technique and the absolute dating techniques. Relative dating techniques try to determine the age of artifacts in a relative manner, whether the given artifact is younger or older than the other ones. Relative methods do not try to associate a specific age or date to the artifact. The absolute dating methods, on the other hand, try to estimate specific chronological age in terms of years. The absolute dating methods are of two types: radiometric methods and non-radiometric methods. Key terms. In this section, we will learn about some key terms by answering the following questions. What are radioactive elements? What are isotopes? What's the half-life of a radioactive substance? What is a radioactive decay and what are the parent and daughter elements? What are the different kinds of radioactive emissions? Radioactive elements. Some elements in nature are radioactive. They have unstable nuclei who spontaneously give off atomic radiation. They emit radiation to become elements with stable nuclei. The word radio in radioactive has come from the term radiation only. The process of radiation continues until the nucleus becomes stable. This process may go on from a few minutes to billions of years. The time for which the radiation is active or on is fixed for every radioactive element. This time is not dependent on any geological or environmental conditions. Some radioactive elements have multi-step radiation process. Scientists use the properties of radioactive elements to estimate the age of old rocks and fossils. Carbon-14, potassium-40, and uranium-238 are some examples of radioactive elements. Isotopes. The atom of every element has a fixed number of protons and neutrons in the nucleus and electrons in the outer shell. The number of protons in the nucleus is used to uniquely identify an atom. Like the atom of the element carbon has 6 protons in its nucleus and oxygen has 8 protons. Some elements exist in multiple forms in such a way that their atoms have same number of protons but different number of neutrons. These forms are called isotopes. Carbon has 3 isotopes: carbon-12, carbon-13 and carbon-14. All these 3 isotopes have the same number of protons, that is 6, but they have 6, 7 or 8 number of neutrons respectively. The isotopes carbon-12 and carbon-13 have stable nucleus, but carbon-14 has an unstable nucleus and hence it is called a radioactive isotope. Half-life. All radioactive elements have unstable nuclei. They try to attain nuclear stability by emitting radiation. Half-life of a radioactive element is the length of time it takes to decay into half of its given quantity. If you take 72 grams of a radioactive substance whose half-life is 10 minutes, it will reduce to 36 grams in 10 minutes. The remaining 36 grams will convert into something else. In the next 10 minutes, which is its half-life, the 36 grams of the radioactive element will decay to 18 grams. In the subsequent 10 minutes, this quantity will further reduce to 9 grams. Carbon-14's half-life is 5730 years. It means if you have 200 grams of carbon-14 today, it will reduce to 100 grams after 5730 years. Parent and daughter elements. When a radioactive element undergoes the process of radioactive decay, a new element is formed. The original element is called the parent element and the new element is called the daughter element. The daughter element may or may not be radioactive. For example, the parent element of potassium-40 undergoes a radioactive decay to yield the daughter element of argon-40. The parent element of uranium-238 gives birth to the daughter element thorium-234 after an alpha emission. Alpha decay. Alpha decay is a type of radioactive disintegration in which an unstable atomic nucleus dissipates excess energy by spontaneously ejecting alpha particles. An alpha emission produces daughter nuclei having an atomic number 2 units less than the parent's atomic number. The resultant daughter element is placed 2 places earlier than the parent element in the periodic table. For example, after alpha emission, uranium-235 changes to thorium-231. Beta decay. Beta decays are of two types, beta minus decay and beta plus decay. A beta minus decay creates a daughter element whose nucleus has one more proton than her parent. It means after a beta minus decay, a radioactive parent will produce a daughter element which is placed at the next position in the periodic table. For example, the radioactive element bismuth creates a daughter element polonium after a beta minus decay. A beta plus decay creates a daughter element whose nucleus has one less proton than her parent. It means the resulting daughter element will be placed one place earlier than the parent in the periodic table. Having understood the key terms, let's see how old artifacts are dated using carbon-14 method. Carbon-14 dating is also known as radiocarbon dating. It is one of the most widely used absolute dating methods. It is very accurate. It can tell how long it has been since an organism died. It can only be used to date organic matter. It can date organic matters up to 60,000 years old. It was invented by Willard Libby in 1940s. Libby was a professor of chemistry at the University of Chicago. He won the Nobel Prize in Chemistry for this invention. Carbon-14 is a radioactive isotope of carbon. Its half-life is 5,730 years. It means after every 5,730 years, the quantity of carbon-14 in a given sample decreases by 50%. Cosmic radiation on nitrogen atoms in atmosphere creates carbon-14 atoms, which incorporates into carbon dioxide in air. Plants consume this carbon dioxide with carbon-14 in their photosynthesis process. It enters animal bodies when they eat plants. This way, carbon-14 keeps accumulating in living organisms. The level of carbon-14 in a living organism of past is the same as that of the present-day organisms. When the organism dies, the concentration of carbon-14 starts diminishing due to radioactive decay. Let's see the method of calculation of carbon-14 dating. It's a simple two-step process. In step 1, first count the carbon-14 atoms left in the dead organic matter. Then count the carbon-14 atoms present in a living matter of the same size. Find the percentage of carbon-14 remaining in the dead organism. In step 2, do the arithmetic calculation based on the fact that after every half-life period, the carbon-14 percentage should decrease by 50%. Let's see an example. Your team has discovered a human jawbone at a fossil site. It was found that only 12.5% of carbon-14 is left in the bone. Let's try to find out how old is the ancient human fossil. You can arrive at the answer by knowing the fact that carbon-14 half-life is 5,730 years. After one half-life, 50% of carbon-14 will remain. After another half-life, only 25% of original carbon-14 will stay. After another half-life period, only 12.5% of the initial carbon-14 concentration will remain. So the jawbone is 3 half-life periods old. When you multiply 5730 by 3, you get 17190. That is, the jawbone is 17,190 years old. Absolute dating by potassium-argon method. We learnt that carbon-14 dating is only suitable to date organic matters that are up to 60,000 years old. To date other artifacts, potassium-argon method can be used. Potassium-argon dating is used to date sediments containing volcanic rocks. Potassium is a major component of volcanic material. Volcanic rocks contain some quantity of potassium isotopes K39 and K41 along with extremely low quantity of K40. The K40 isotope is radioactive which decays to calcium and gas argon. Suitability of potassium-argon dating. The half-life of potassium isotope K40 is 1.2 billion years, which is much longer than that of carbon-14. Because of this, K40 dating can be used to date rock samples up to 4.6 billion years old. Most of the ancient hominin fossils in Africa belonging to the genera of Australopithecus, Paranthropus, Kenyanthropus and Homo have been dated using this method. The potassium-40 dating method was used to date a rock on the surface of Mars as well. Let's see what are the limitations of potassium-argon dating. It can only be used to date volcanic rocks and other materials that contain potassium. It cannot be directly used to date animal fossils. Indirectly, it can be used to date the volcanic rock layers between and above the animal fossils and then apply the relative dating techniques to date the fossil. The accuracy of K40 dating is not reliable for a specimen under 100,000 years of age. Let's understand the decay process of potassium-40. Potassium-40's half-life is 1.25 billion years. It decays into calcium-40 and argon-40. About 89% of potassium-40 decays into calcium-40 and only 11% of it decays into argon-40, which is a gas. Let's understand how argon-40 accumulates in the mineral samples. In volcanic rocks, potassium-40 decays into argon-40 gas, which is trapped within the mineral crystals as the molten volcanic rock cools. This argon-40 gas cannot escape and keeps accumulating over a period of time. The ratio between potassium-40 and argon-40 is used to calculate the age of volcanic rocks. Absolute dating by uranium series method. The third absolute dating method is uranium series based. Uranium late dating is one of the oldest and the most defined of the radiometric dating methods. Uranium series dating is especially useful in the regions that are not volcanically active. It is particularly useful in cave sites because uranium is frequently introduced into caves through slow flowing water. Half-life of uranium series is long, allowing scientists to date very old materials. The world's oldest rock, Canadian Acasta gneiss, which is 4.03 billion years old, was dated by uranium lead method. Uranium isotopes. Uranium is a radioactive element. It constantly emits radio particles and mutates to other elements. It has a well-established radioactive decay series. Its three isotopes, uranium-238, uranium-235 and uranium-234, are naturally occurring and all are radioactive. Out of these, 99.28% of natural uranium is uranium-238. 0.72% of natural uranium is uranium-235 and 0.0057% of natural uranium is uranium-234 isotope. Uranium-238 has the highest half-life of 4.468 billion years. Multi-step decay chain of uranium. Uranium-238 emits alpha particles and decays into thorium-234. Thorium-234 is also a radioactive element. It emits beta- particle and decays into protactinium. Protactinium decays into uranium-234 after emitting beta- particle again. This uranium isotope is once again radioactive. This multi-step decay chain goes on and after 14 steps it finally transforms into the stable nucleus of lead-206. You can see on the screen that each step of the chain has a well-defined half-life that varies from 1.17 minutes to 4.468 billion years. These intermediate decay steps are also useful for dating. Uranium series dating process. The uranium dating method relies on measuring the relative concentration of isotopes within a rock or mineral sample. Two measuring techniques exist. Technique 1 places the sample in a nuclear reactor to excite it and then measures the isotopes using a mass spectrometer. The technique 2 places the mineral grains under a spatial microscope and ionizes the grains through a laser beam, and then isotopes are measured by a mass spectrometer. Once the concentration of isotopes is known, the age of the rock is determined by putting the half-life into the dating equation. Let's conclude what we learnt in this video. We learnt about 3 radiometric absolute dating methods. We should use carbon-14 method to date organic material which is less than 60,000 years old. We should use potassium-argon method to date ancient volcanic rocks. Finally, the uranium method should be used to date non-volcanic samples. Now we come to the end of this video. In the next videos of this series, we will be learning about the non-radiometric absolute dating methods and the relative dating methods. I hope you found the video to be useful. Thank you.